project title is Cluster-Aid Election Using Fuzzy-Based Logic. Our team members are P. Shenbagavalli, M. Vijayalakshmi and S. Saranya. And our project guide is Mr. G. Vijayalakshmi, ME, Assistant Professor of EC Department. We published some journals. First paper, Cluster-Aid Election Using Fuzzy-Based Logic. Second paper, Secure Route Discovery for Dynamic Source Routing in Manets. Literature survey title, Cluster-Aid Election Mechanism for Wireless Sensor Network. Author P. Wang, GP, Su, CB, LI, BJ, Chened, B. Chenna. Literature survey 2. A hybrid energy efficient routing using a fuzzy method in wireless sensor network. And author is Izzat Arabi. The main objective of our project is to provide high energy efficient lifetime management system for wireless sensor network, and the technology used is energy management in wireless sensor network. The main abstract of our project is the sensor nodes are densely deployed in hostile environment to monitor, detect and also to analyze the physical phenomena and consume considerable amount of energy while transmitting the information. It is sometimes impractical and sometimes impossible to replace the battery and to maintain longer network lifetime. So there is a limitation on the lifetime of the battery power, and energy conservation is a challenging issue. Leech, the concept of leech, the low energy adaptive clustering hierarchy is the most famous hierarchy routing protocol where the cluster head is selected in rotation basis based on a probabilistic threshold value, and only cluster head are allowed to send the information to the base station. But in this approach, a super cluster head is selected among the cluster head who can only send the information to the mobile BS by choosing the suitable fuzzy descriptor such as remaining battery power, mobility of BS and centrality of the clusters. WSN introduction. WSN involves two types of nodes, sensor and actors. Sensors are inexpensive and highly constrained in energy and processing capacity. Actors are more capable node with a relatively more on-board energy supply and richer computation and communication resource. In many real-time applications, robots are used as actor nodes. Introduction. A wireless sensor network consists of spatially distributed autonomous sensors to monitor physical or environmental conditions such as temperature, sound, pressure, etc. and to pass their data through the network to a main location. The more modern networks are bidirectional, also enabling control of sensor activity. The development of wireless sensor network was motivated by military applications such as battlefield surveillance. Today, such networks are used in many industrial and consumer applications such as industrial process monitoring and control, machine health monitoring, and so on. Characteristic of a wireless sensor network are power consumption constraint for nodes using batteries or energy harvesting, ability to cope with node failure, mobility of nodes, communication failure, heterogeneity of node, scalability to large scale of deployment, ability to withstand harsh environment condition, ease of use, power consumption.
Our existing system is LEACH protocol. LEACH means low energy adaptive cluster head. It has been developed based on clustering mechanism to select cluster head using optimal probability. The protocol works on periodic randomized rotation. That means in the cluster edge between zeros and 1, if the random number is less than the predetermined threshold value, the node becomes CH of the current node. This is the cluster head selection process. If the nodes are numerous nodes are in our wireless sensor networks, the single node acts as the cluster head and the remaining act as the cluster node. If the cluster node gives the information to the CH only responsible to send the information to the base station. Base station in the sense of destination point, it is the cluster structure illustration. The dark blue color illustrates the cluster head and the remaining one is the cluster node. It gives the gateway of next node, next cluster nodes, and the cluster member act as the ordinary mode. Connected dominating set in the means of the dark brown color gives the shortest path to send the information from source to destination. It is the cluster merging process. Merging process in the sense of cluster nodes will be merged. It is the dominating set illustration. Dominating set illustration in the sense of cluster nodes are joined with another cluster nodes. The demerits of leech protocol is the main demerits is it is not gives the guarantee and acceptable cluster head distribution. Due to lack of support in deploying network with a large number of sensor nodes, protocol cannot be used in the large region. So leech suffers from significant energy consumption when there is no CH selected in some rounds. It is the major drawback of leech protocol. By this, the WSN should not have the high efficiency. So we go for the CHEF protocol. CHEF protocol means cluster head election using fuzzy based logic. This is our proposed protocol. In our proposed system, there are three main parameters are considered to elect the cluster head. The first one is residual energy. Residual energy means the own energies of each and every cluster nodes shares their energy with neighboring nodes. Node centrality, it simply denoted as NC. It shows the central node among the neighbors of network. Local distance LD, this is the sum of the distance from the deployed node to its neighbors. Architecture diagram, the topology creation means how the route path will be created in the WSN to transfer and receive the information. Route discovery means route it has two parameters. One is route request and the route reply. Route request means if the source node gives the route request to the each and every nodes in the network, the which node gives the route reply. This was the shortest path in the wireless sensor network. By this way, route discovery can be discovered, and the cluster head election is based on the process node shares their energy. This means the residual energy. The high energy nodes act as the cluster head, and the nodes will monitor the neighbor node energy and link capability. If it may have the chance to drain the CH, it will automatically request to form the second CH. CH will dynamically change based on the priority level. Balanced energy will be maintained and the data from transfer CH to base station. We have the 5 modules. One is topology formation, communication model, cluster formation, cluster selection, cluster head changes. First, the topology formation is similar to the route discovery. It means a source and destination. It gives the route request and the route reply. From this way, receives and transmits the information with route for data traffic. Communication model, creating sensor nodes and the sync nodes. Nodes will replaced with the range of neighbors. Cluster formation is formed with respect to the mobile wireless HADAC network. It simply says that managed network. The cluster size should be controlled so as not to drive too large neither too small cluster. Control message broadcast period should be dynamically adapted to avoid unnecessary message exchanges. The red color sees in the diagram, the red color nodes act as the cluster head and the remaining yellow color it act as the cluster nodes. The large rounds is the cluster and the remaining small nodes is the cluster nodes. By this way, the information can be changed. Cluster head formation is simply says that the 3 parameters. One is residual energy, mobility, and the distance. In this figure, the red color acts as the cluster head. The information is passed through the one cluster nodes to another cluster nodes. Also, it satisfies the FA forward aware factor. CH will select if the node has satisfies these parameters. In cluster without CH, every node has to store and exchange more topology information. It eliminates bottleneck of CH. Bottleneck means the error arises in the cluster heads. Cluster head changes in the sensor nodes. If we forming the clustering mean we can improve the network lifetime is possible, but the constant there is a different cluster head changing algorithm is available like as leech. In that algorithm, cluster head changes will be in random manner, so that may change chances to reduce some particular node energy. To avoid this problem, we are using the HEF. It is the head efficiency factor algorithm. Each and every second calculated energy is going to store in energy list. Whenever cluster head duration is over, then we are comparing energy of each and every node in that list, and which one having high energy in that list, we are selecting that node as the cluster head for the period. This is the cluster head changes. The advantages of WSN in that CHEF protocol is increased the network lifetime and the reduced data gathering delay in WSN to approximately changes the cluster head. Low energy consumption in WSN. Requirements, our software requirement is Linux and the network simulator version 2. Languages, front end used the TCL language and the back end uses the C and C++ language. Hardware requirements is simply the RAM and the hard disk space. It only 20 GB and 512 MB. Model TCP program is first we have the source node and the sync node and the connecting node. It is denoted as S1, K1 and SRC sync. Our UDP agent is attach agent. Its packet size is denoted as 536 and it only connects the node code. We have the output in two ways. One way is NAM window and the second one is XGraph. NAM window means network animator window and the normal graph representation is XGraph. First one, NAM window output is NS. NS means network simulator, so it denoted as NS NAM project, network simulator animator project. The purple color one denotes the purple color is the base station and the dark blue denotes the cluster head. The large round one is the clusters and the black color is the cluster nodes. This was the NAM animator project. It is the XGraph. The x-axis denotes the packet delivered and the y-axis denotes the time. The smaller red color one is the normal cluster head election output and the green color one is the leech protocol output and the blue color is the our CHEF protocol. By this one we have the conclusion. Our CHEF protocol have the highest energy in WSN to transfer and receives the energy. These are our reference books and the authors. We use the Ubuntu software to run the program. In that one we have the network simulator software to run the program. Our program is in main.tcl. This is the coding. BS means the base station. The data will be sent through the base station. NS is the network simulator. This is our coding. If and else condition, we have some failures, it will directly proceed to the another cluster head election. This was denoted in the if and else condition. It would be run at press the keys of Ctrl plus L, Ctrl plus C, Ctrl Alt T. Automatically opens the terminal display. After that we have to put CD space Ctrl Shift V. In the Ctrl Shift V makes to paste the main program. Next we have to enter the NS means network simulator. Our program is in main.tcl command. Then we have to enter and the program will be starts at 0. The command line will be proceeded until it will executes the sensor networks. The command line will be run until 0 to 7. This is our terminal window. The program will be run until the graph will exist. Finally, we got the output. It is the network animator. We have the several output. The executed output will be the X graph. This is our throughput graph. In x-axis we have the time and y-axis we have the packet sense. It will increase the efficiency of networks. The data transmission and reception will be comparatively higher than the existing protocol. If we want the network animator, we again executes the program with respect to ns space main.tcl. Again the command line runs until the graph will executes. Finally, we got the network animated output for command line 1. This is our NAM window output. The green color rounds are known as nodes. We have to play the window for how the clusters will be formed. The large circle means the clusters which have the node will be formed. The steps in the end of the toolbar which increase the time of transmission and reception of information. The end of the window bar gives the 13, 17, 18 means centrality, mobility and the frequency of a fuzzy which selects the cluster nodes and the cluster heads. The black color, the line crossing the from cluster to cluster, it is the information sense. The black color node, the black color which is the cluster nodes, and the blue color gives the cluster head, and the red will be the failure occur in the clusters. Automatically the green color will be changed because the cluster head automatically changes over the period. By this way the cluster head will be chosen by the fuzzy based logic. Fuzzy is nothing but the cluster head will be elected by either or else and true or false manner. If for the condition of if, it will elect the cluster as the head, otherwise it will elected head as the another cluster. By this way cluster will be elected as the head for the whole cluster for appropriate transmission and reception of information in wireless sensor network. It will automatically increases the efficiency of wireless sensor network. Again we attain the graph with graph of throughput. Same, it has a x-axis as the time seconds and the y-axis as the packet delivered, which has the high efficiency compared to other existing protocols. Here we have the another graph. It is the energy group graph, and it has high energy when compared to other protocols. From this Chef protocol we have the several advantages. Mainly the three advantages is increase the network lifetime and the reduced data gathering delay. It means reduces the data traffic in WSN and low energy consumption in WSN. The energy will not exist at higher rates compared to other protocols. It will consumes only the low energy.